At first, I'm going to show you the end result, so you have an understanding. Then we are going to work with them. So let me show you examples here. So for the first example, we are going to create an image like a gradient, like if you work with Photoshop and these things. So, this is an image we are going to make. For example, let's say it has a width of 800 and the height of the 600, right? So we have an image, like a very typical image. And as you see, as we are going toward the x-axis, it's getting the reddish color. And as we are going to the y-axis, it is getting greenish color. And as we are going toward like diagonal, it's bluish. So, but as you see, it is like a combination of those. That's why it doesn't have any exact, let's say, blue or red or something. So, as you know, like colors, one of the ways to show colors and pixels, like the most typical way, is using RGB code. Okay. I'm going to talk briefly about like the basics, about the concept and what is RGB, and then we will go to the examples. So we are, as I said, like each pixel here has a RGB, means red, green, blue. So our aim is, as we are going toward here, the red cell will going to be increased, green in this, and diagonal will be blue. So for here, the 0, 0, 0, everything is 0, 0, 0. So it is like the minimum number possible, which is black. As you know, 0, 0, 0 is black wherever you put RGB code. And 255, 255, 255 is white, pure white. So one of the other things, of course, I know you know it, but I just repeat it, is the maximum in RGB, let's say, in RGB, the value is 256, okay, which means it can be started from 0 to the maximum number of 255. So each red, green, or blue. So that's it. So let's then you know that based on the movement, we are going to increase which color and which field. So let's try to work with it, and let's try to create such a things. And of course, for creating image, for reading image, we are going to work with PNG file format. And in C++, for working with PNG, you have to use some specific libraries, which we are going to use and we are going to explain. Okay, so I'm going to close this and go back to our, let's say, work. So here, as you see, it's like almost empty template that we are having. You already are familiar with this part, which is for the like Cuda. If some comments fails, it gives you understanding that on which line what was the problem, and we have an empty main function, and we are going to work. Okay, so let's before everything, I just explain you we are going to work with PNG file format. So we need a library, except this Cuda and everything like default things which I put here. We need a library which is not built in C. Okay, it is already it is. We are working with a library. It's called pngo. It's some kind of wrapper. Okay, it's some kind of wrapper on the normal PNG++ library, which is provided for you in this utils. You see pngo in this utils folder. Okay, so whenever you like the default settings of this TIA is configured in a way that whenever you create like the first, when you copy and duplicate a project, it already includes these utils, which is included this pngo library that we are going to work with it. So even you can put it on different folder or whatever you want. And for those of you, maybe for some, I don't know, maybe you played too much with this TIA environment and you lost this folder, I will put it on Moodle as well. So you can download it and put it, this pngo cpp and pngo header file inside your folder. So let's talk about like basics in C++. So let's say, as I told you, I'm not going to start the project yet about the configuration. You are going to use a library which is not the basic ones. So you have to explicitly say where it is located. So means just like importing a normal library. So at this point, I'm going to import work with pngo. So I will just put a simple include, okay, and then the path of the your, let's say, C++ file. For example, I am here. This is my main. So it is inside utils and this guy header file here. So I just simply put the path. Of course, if you put it on the different, let's say, different folder, you have to give that as the address. So utils / pngo.h. So that's it. I'm going to work with it. So I just do my imports here. But as I said, you have to import it to be able. So I will show you how to work with PNG as well. So that's it. So I already told you that we are going to have an image with some weight, some width, and some specific, let's say, size. Okay, so let's define it in our project. So just like previous project. So we have some definition, define. So let's start with the block size. Just things you know at the first. So block size, I'm going with 16 for the sake of consistency. So this is the first define. Now our two new ones. So I'm going to define width, right? And I told you like it is like 800, let's say. So 800, and the same thing for height. So define. Okay, and this guy would be 600. So a typical normal file. So I'm just defining width and height and block size. Okay, so as always, let's start from our main file, and then we will go back to a kernel which is going to run on device. So first, start with the first basic things. So let's start our project with saying, okay, we are going to use this and that, like some kind of basic prints. So if I just use cout, so I would like a std cout, and I'm going to say creating the image. So at first we know that our program has run successfully with like please wait a bit or whatever makes you happy. So and then go to the next line. So again std this time end line. So that's it. So you know this by now. Okay. So we are going to do actually our memory allocation and these things and so on. But before that, let's see and calculate how much memory we need to allocate, right? So because we want to know like how much memory we need, so allocate it from the memory and then the same amounts for the GPU and so on. So I'm going to define a size for, let's say, how much I need memory. Okay, so basically, you know, if look at it, so we have it's a rectangle, right? So it will be this like width, height, multiply to width, which is like the area. So we know like basic mathematics, right? So we have width multiply to height, right? So and we are going to, as I told you, we are going to have for each RGB color, each pixel, we are going to have from 0 to 255. So a simple unsigned character will be enough. So multiply to size of, right? I'm not using integer? Because as I told you, we only have 256, which is the maximum value for the RGB, so I don't need to use too much memory, which is not going to be used. Okay, so unsigned character. So here, right? So let's think, is it enough for us? Not exactly, because now we have assumed that each pixel has like one cell. But each of them, if you, it's RGB, it should be red and green and blue. So we need everything to be multiplied to 3. So because width and height, and each of them size of character, but of each of cells, I need 3 to be able to show the RGB color. Okay, so now I have width and height. So you should know, I have a diagonal as well, because I told you I'm going to go to this line as well and fill it as we are going with more blue, and more blue. So I need a diagonal as well. This line guy here from these two corners. So let's define it as well. So at first I'm going to define it on host. So I like put it like diag, which is like short form from diagonal, and it has a len. So okay, if you remember these things which I'm going to say, it's not like computer, it's mathematics. We have height and width. So for calculating this, it is like a square of, under a square, it is like width by the power of 2 plus height by the power of 2, right? It's like simple mathematics. So as I told you, like this guy by the power of 2 plus this guy by the power of 2, all of them under a square. So let's like talk about it in mathematic form. So so I need some square, right? So S Q R T F is like for getting a square, but I'm going to get a square. Why? For having this function, you have to import this math here, which I already included. So just don't forget it. So as I said, so the first thing is we have to like have width by the power of 2. So for that we have a function power, power, and in this I'm going to width and 2, right? So this is for the width part, and then we are going for height, the same thing. Oh, yeah. So this time height and 2. So now we are going to calculate this guy. So it is saying like, okay, you didn't define this function, this variable. So let's variable define it somewhere here. I'm going to say it's going to be double, right? Because it's like under a square, it could be 1 point something or something. So for that reason, I'm going to define it, and it would be a double, let's say, because it has like point something, and h underline saying the name diag, yeah. And at the beginning, I'm going to set it like to 0. So that's it. So here it is safe now. Okay, now we calculate like the mathematic parts. At this stage, I'm going to copy this guy here to my device. But one thing I want you to know, right? Okay, now I calculate this amount, okay? And I'm going to send it to the Cuda memory. One of things, yeah, basically you might say, okay, you can send it as an argument of a function, right? To send it to the, but I want you to know how that Cuda has something called constant memory. When this amount is set, it is a basically type of constant. So for this reason, for this specific reason, I'm going to define a constant, and then I'm going to copy this value to the constant memory of the CUDA. So for this, I'm going to define a constant. For the constant, you basically, so this is, I'm going to have it. This, I want to put this value to the CUDA memory in the constant memory. Of course, there are other ways. You can send it to the Argomon and everything, but I want you to see the different types of, let's say, sending, working with data. Then you can choose which one you use based on the situation. So the same thing, double, this time device diag, let's say length. So I have defined a constant for CUDA, and now I'm going to copy this guy to this guy. Right, okay. So for copying this, just like the normal way that you were copying with CUDA memcopy, if you remember, here, let's say I'm going to write some kind of comments and say like copying to constant memory. So you can understand what I'm doing basically. So as you know, CUDA check return, I will put everything here, but what I'm going to do. So you might say now, okay, you're working with CUDA memcopy just like always. No, basically, it's similar function, but with a slight different. CUDA mem, and I think it's copy to symbol. Why I'm using that? Basically, because I'm going to copy inside the constant memory of the CUDA. Okay, for the arrays, you do the normal way. What this is constant. So I'm going to copy to host, sorry, the device diagram. What I'm going to copy, I put the address of host diagram, and which size? Size of double, because it's double, right? So pretty simple. So yeah. So yeah, this memcopy to symbols has different works. It's not the only usage, but one of which is copying to the constant memory of the code. So that's it. I am having it for now. So now that we set these things, we continue with what we always do. So I'm going to have memory. I just here defined the size, but I didn't allocate any memory for my host. So I have an image on host, and I'm going to get some memory for it. So I will going to write an unsigned char. As I said, here I'm using character or char because my values is from 0 to 255. I'm calling it, the name of the variable will be h, for example, image, so host image. And I'm going to, again, unsigned char, and yeah, and malloc. How much memory? Size. I define it here for this specific reason. So here, so let's make it nicer. So then that's why I'm going to use like allocating memory. Yeah. So the same thing we do for the CUDA as well. So allocating memory on host for the image, let's say. So now do the same thing, but this time for the device. So I will write allocating memory on device. Okay, it will getting cooler. Don't get bored. So then I need another the same thing like unsigned this time character. Sorry, unsigned char, and of course a pointer for this time my device image, same thing, device image. And okay, let's allocate it again. CUDA, you know the rules. CUDA check return, and it's CUDA memory alloc, CUDA mem, sorry, CUDA malloc, yeah, and how much? First, name of my variable is the image. Okay, and how much I want? Of course, the same amount I do for my size. Close the back. This guy. I have a typo here. Yeah, size. Yeah. Okay. Good. So, you know, yeah, I'm happy that you're getting the logic behind it. So allocating on device, allocating on memory, and of course, configuration of the kernel size and these things. So let's go for the configuration of kernel size. I mean the grid size, block size thing. Okay. So you might say, okay, here you already defined block size. You already see in matrix multiplication, we have 2D memory allocation here. That's why I already told you we have a struct called dimtree that helps us to have multi-dimensional kernels and grid size and so on. So let's say I will call it configuring block and grid size using dimtree struct. Again, since we have 2D mem here. Okay, not nice line, but yeah, you get the idea. Okay, so we go with dimtree struct. First block size, let's say, something, whatever you like. And it will be, I already defined block size, right? Block size and block size. It will just make it multi-dimensional. Nothing too much to be scared about. That's it. So this guy to this guy. But for the grid size, since this time it's not like a square matrix, my height is 600, my width is 800. So a bit might be things different, but we will see. So again, dim3 this time will be grid size, right? And for this grid size, I'm going to use the tricks that we always use. For example, which is width plus block size minus 1, those padding things, so we don't lose the memory, we don't mess with the memory. And of course, the divided by block size, you already see that. But this time, let me make it nicer here. So, okay. But this time, it wouldn't be just again width. This time height, right? So height, I'm just making it multi-dimensional. Minus 1 again, divided by block size. Block size. Here. So basically, we did that as well. So we have a block size, which is just like always block size. We have a grid size. The grid size is the size that blocks are inside. We get it multi-dimensional, but one dimension as the size of the width, one dimension as the size of the height. So that's it. Now let's run our kernel, let's say. Okay, but I didn't define it yet, but of course. So for running our kernel, let's put some kind of fancy name. I call it like create, for example, I don't know, image, for example. And you know the structure. Okay, here grid size, and just put it here. Yeah, grid size, and the block size I just defined. So block here, this guy here, and size here. What to send exactly? Okay, you're going to send your device image, right? Because we are going to work on that. So, this is that's it for now. And we are not going for now copy anything to the kernel, because we are going to create by the kernel. If we wanted to modify something, we have to repeat first and then run the kernel. So here now, let's say create such a function for our kernel, and then then we will see how it's going to work. Okay, so We have grid size and this, and now let's go up, just like always. So here, you remember how to define a kernel device. So basically, global, yes, you know it. Global void, what was the name? Create img. Right? Let me check if it was the same way. Yes, create img. So I'm not messing with it. So that's it. And what is going to get? Of course, a pointer, unsigned, no, sorry, unsigned, char, and char. So this guy is this what I'm sending here. This. Okay. So now let's define it. So you know when we are working just like matrices, we are going to have a x and y for each pixel. It has a x and y. So let's get our threads x and threads y. Okay. So again, unsigned, let's say int x, which is equal to block size. You know this part already. Block uh, and id x dot x this time, multiply to block dim x. So it shows which block we are in, and then of course which thread. Thread idx, right? So the same thing we are going to do for y. I'm just copy pasting it so to save the time. But this time all the x's will be y, right? Y, y. So we have our x and we have our y. So now let's create an image. Okay. So for the thread number, as you know, it's basically some kind of a matrix. So I'm going to have put some kind of I. Let's say we have I for just naming, labeling each threads which we are going on this matrix basically. So we have a, let's say, unsigned int I, which to know which thread we are, and so it is a matrix, right? So basically we have to we are going on different rows, and on different rows which block. I already, like, I'm not going to repeat the concept again because it is on the matrix multiplication I already showed you. So it would be I multiply to width. So it is basically showing which row we are, okay, because we have a y, and based on this, which row we are and which column we are. So plus x shows which column we are. Okay. And of course, multiply to 3 because we are working with RGB. I already told you that each pixel is basically 3 number. Okay. So that's it. Now that we are here, we know that we are going to move on each cell of the matrix. This I is an identifier. It is just see it like a matrix. It is the row number plus y shows which column we are, and multiply to 2. Okay. Now the image part is going to be a start. So I told you that that we have 3. Let's say we have 3 R and G and B. So I have an image, right, which is, let's say, okay, I think I made a mistype here. It should be image. So I have an image here, right? So and in this, and this image has an index, for example, I. Okay. So also we have it. So because I want you to understand it. So the other thing is image. This time I plus 1. This, let's assume this one is red. This one is green. The next one is green, and the next one is blue. So I this time plus 2, right? So that's why I multiplied it by 3. The first one is R, the second one is G, and the third one is blue. Okay. Now what we are going to put? Now what I explained to you. I told you the first one I wanted, as we are going toward the x-axis, okay, I want it to be more reddish. So, which means that, okay, if I multiply it by the width, okay, so it means like, let me write it and then I will explain it. Okay, x multiply to the width. Okay. Okay, so you know the maximum is, the minimum is 0, the maximum is equal to width, right? Because we are from x to the width of the maximum size of the let's say image. So if it is equal to this, it will be, the maximum will be 1, because there's two values which are the same. If you divide it, it will be 1. Okay, so basically as it gets higher, it will be maximum, it will be 1. Okay, so I want my 1 to be 255. It's just like getting percent. So multiply to the maximum color possible makes it from 0 to 255. And of course, since it is a division, I'm going to make it float. So yeah, so this means just think again. Okay, I think I need this. Yeah, this thing. So as we are going to the width, this gets higher and we will have higher red. So you saw the concept. The same thing, but this time for the height. So float, this time I put it y, multiply to the height, and of course, just like getting percent, but this time the maximum is 255. So RG, okay? But for the blue, as I said, since blue is diagonal, I'm going to do that mathematic, write that mathematic function as well. So which is SQRTF, again, hover, this time x by 2 plus hover, this time y by 2. So this is my power, and let's close it. Yeah, parentheses, right, and all this time divided by the size of the diagonal, which is here. I just copied, so it is like the diagonal, and of course again multiply to, so it is a ratio but for this line. Okay, so that's it for now. Okay, so we have R and G and B, simple. So you know, but one thing we should notice, for example, my let's say block size might be bigger than the image itself. So I'm going to just write a boundary, which I'm saying do this only if this x and y are smaller than width and height. So I'm writing here just boundary, and I say if, of course, x is smaller. You already know this concept. Width, and the same thing for y. Y, but this guy smaller than height. Okay, so that's it. And then I'm going to put everything inside this. So I'm just saying, if, for example, there were a thread size which is bigger than my image, why should I put a pixel? Let's say if I'm here, why should I put a pixel? That's why I put a boundary, and I say if you are smaller than this guy, you're smaller than this guy. This is exactly this line. Okay, so let's go back to our let's say part, And so yeah, this time, okay, here, okay. So well, you remember always when we were after running a kernel, we were waiting for it. So we write like Cuda check return and Cuda device synchronization. Just you already see device synchronization, synchronize, yeah. And I'm going to, yeah, sorry. Okay, so these guys two together. Okay, but let me write here. Let me write commenting like running kernel. Yeah, so we're going to work there. But this time, this is, of course, this is not mandatory, but let's be creative and let's see, for example, it is interesting, right? How much time uh, was spent for running this guy. So let's set a timer and calculate from before this and after this. So we will understand like how much time we spent for running this guy. So for this, I'm going to use OpenMP library, which is a like library basically for maybe if you had parallel programming algorithms, you already are familiar with it. But well, if you are not, it's all fine. Let's use some functions. It provides us for these purposes. So I'm going here to this time include. As I said, now this time I'm going to use it to get like how much time we spend on our kernel. So it's like OpenMP library. It's called omp.h. Okay. Yeah, exactly. Now omp.h. And if I include this, I have some kind of functions that helps me to get the time. So let's see what do I mean by that. So basically, I want to have like a start time and a finish time. So I have a double, I call it start. So it's like time before the guy and time after the guy. So the function is I think OMP and get wait time. So this is before, and let's do the same for the after that. Of course, it is not has nothing to do with the image itself, but let's see it, and you can work it on your own on different projects as well. So this time I'll put it like end. So now I have a starting and finishing point. Let me put an enter to be nicer. So I have this for now, and my kernel had been run. And if you remember, after running kernel, we were copying back the device, the information from host to the device back. Okay, so I'm going to copy back from device to host. It's like the image which is calculated, we just calculate. So just since it is our law, we always like Cuda check return. And inside that, of course, Cuda mem copy, not Cuda mem symbol, because we are working with the array. So Cuda mem cpy, which is Cuda mem copy. And inside this, our destination is host image, of course. From device image, I'm going to copy it, right? And the size, which is I defined it here, this size, and of course direction, which is this time from host to device, sorry, from device to host. So Cuda mem copy device to host. So I'm having it here, right? So I have it back here to the H image. So okay, now that I have it back, now I told you my aim is to create a PNG file, of course, right? So let's use that PNG library that I just imported. It's, as I said, once again, based on PNG++, which is a C++ library, and it's just make it easier for us. and let's create an image. It's pretty simple and straightforward. So if I create a png image, okay, and the structure is like some kind of class template. So if I write like, yeah, I have the png and yeah, double, and I'm going to create an image which is png in RGB format. So it has RGB pixels, and a name for the class. I call it image with width and height. I already mentioned above. So this guy will create an image for me, and with this name. So let's put our information to this guy. We just created it, and now let's put it to this guy. So again, we use this PVG, and this time since we have RGB colors, right? I already said we have RGB to PNG. This is the function it provides, and to the image which I just create from where this guy. So it gets this and makes it and put it inside the image, right? So host image. Once again, we create the image with this height and width with the simplest structure. Then we want it from RGB to PNG. It's like this is the destination. This is the source. This is the destination. Okay, and let's write it on disk. Write image on disk. So since it is some kind of class, so it's object. So I call it like image write, right? Right, and you should provide a path. I want it to be in the same folder, so I will like output dot png, not JPEG or something, because it's only work with this. So as always, and for the sake of the democracy, we are going to free everyone. So free h image and Cuda free. This again, Cuda check return. Cuda free device image, of course, this time device image. So we freed them as well. So now it should work, but we will see if it works or not. Okay, now we saw our data, and we wrote our code. And so let's create our CMake file. This time, I want you to know, this time our CMake file is a bit different. And why it is different? Because here we use some external libraries. You see, we like every time we were just doing like a basic thing, we were just using, we didn't need to change it, right? But this time, since we use two libraries, we have to link them with our project. Okay, how to link them? The external one, it should be linked to our project. This guy, which is for using writing and creating PNG files. So for this, I will show you how. First, I want you to know something. CMake has a package that checks that before compiling your code, you have to have already some libraries. Which means, for example, if I write find package, so which means this png lib should be at first find this png lib that is on my computer. So and I set it as required. Required means I need this library. Of course, I need other library as well, which is OpenMP, because I used it for getting time. So OpenMP, I think name is like capital P. Yes. OpenMP required again. Require. Yeah. So I have these two. Okay. And for this, I have to have, let's say, to set some compile flags. So means what is compile flags? Though I don't want to like go too deep on the CMake files, but it is like, because we are using some kind of libraries, like in this case OpenMP, we have to set a flag for our compiler. So for this, I'm just like very fast. I just append CMake cxx flag. I'm going to set a flag. Yeah, flags, I think it should be, and then it should be open mp cxx if you're using this library flags. So, and inside quotation. So I'm setting this flag, and of course, just like always, add executable file. So this is from main file. And one other thing I have, you should specify your external library as well. In this case, this is in utils pngo cpp. Okay, so I have to just name it. So the other, it should be, when you have one source, you only specify that source. But since here we have two different sources, like this guy, I have to add it to my project as well. So I call it like utils /pngo.cpp. Of course, if your name folder is different, you should change it. So don't just repeat what I say. Depends on where you have put your file. So, and I have to link everything, these libraries together. So there is a command in CMake, which is called target and link. Yeah, hopefully it has autocorrect. So this time the name of my file, the project is class. Yeah, and this, if I write my PNG library, it automatically will link PNG library with my project. PNG library. So don't get confused too much with this. As I said, for compile, when you are using external sources, you have to specify the source and also link it to your project. Okay, not much different, but yeah, for this project, for this aim, you have to do this. So let's save it. I saved it, and I think I already calculate the time, but I think I didn't printed it. So I mean, like, let's I have a start time here and end time here, right? So let's print the time difference to know that, okay, the project, for example, done in this amount of time, and so on. So for this purpose, at the end, like after creating this image, I just remember that I will write for cout. What do I want to say? I want to say done in some amount, right? Amount of time. Which amount? Of course, end, which is here, minus this guy. It will be the difference between these two. And minus start. And since it is in seconds, so seconds and milliseconds actually, but yeah. And then go to the std and line. So that's it, right? So I calculated time, I created image, and everything should be set. We will see if we are going to get an error or no. Let me set this guy somewhere else. I don't know. Here maybe. Okay. Yeah. So let me save it here, and then we will go there. So C blah blah. I'm going to go to my project. It is in this folder. I called it 0. So cd 0, and let's create a build folder. So mkr build just created. You, of course, you can create it manually with right click as well. So I will go to cd build. So my CMake, hope it works well. Okay, it says like f open not found. Maybe I messed with some names. I'm not sure. Let me see it again. Okay, it says like open mp underline cxx flags. All right, open mp required, and this guy here. So let me once again, let me see if everything here is okay. Append CMake CXX flags. I think I know what I missed. You know, for all when you have like a specific let's say variable, you have to put $sign, just like here. I forgot it to put it here. So hopefully it fixed the problem. So let's CMake. Let me save it and let me. Hello?
Uh, the find package, the first one, png required, U is missing in the first one.
What?
U, find package.
Okay.
png required.
Okay, thank you. Thank you for mentioning it. Yes. When you are too used to these autocomplete things, these things happens. Thank you. Okay. So I hope this time it works. Yeah, let me delete this because it sometimes it has rm-f rm-r build. Okay, again make dir build. Okay, again CMake. Because I'm not in the build folder, cd build. So CMake. Okay, let's see. So done. Yeah, this time. Thank you for the mentioning. Yeah, it was done. And now let's make our file, and we will see if we will get an output or no. So let's compile it with make function. Yes, done successfully. And let's run it. Creating the image, and it says done in this, right? And it gave me this output. Okay. Unfortunately, this TIA cannot help me to show online, but let's download it and see. Because if I just double click on it, it will shows like 0101 message with it. So let's see. Yes. You see, it shows it like this, but I want to download it so you can see it inside. Sometimes this TIA just gets crazy. Just wait a moment. Let me prepare the download. Let me refresh the page. Okay, yeah. So again, let me download it. I just want to show it to you. Yeah, hopefully. And here, let's create a folder called class Cuda, just something. And I'm going to set it here. Then let's go. Let me. And it says class Cuda. Yeah. And let me extract it. Extract class Cuda. I just wanted to be able to show it to you. So I just downloaded it and let's see. See, you got the image. So as we get here, as it goes higher, the same thing I explained. It's the red will be here will be the maximum red. It means like the number of, so see each of them like I, because I called it I. Let me move it here to the here. No, let me make it smaller. So, and I want you to understand. So here, as you see, first here we say if you are longer, bigger than is, and then bigger than is, then don't do anything. The I is number of row plus number of column. This Y is for example at first these rows. So each row is Y multiplied to the width, which is this guy, which means like first this let's say this guy, this guy, this guy, this guy, and this X shows to the column, like which, for example, this is first row, second row, third row. This X shows like, okay, where in this first row, where in this second row, and of course multiply to 3 because each of them are 3 pixels. So, and we say as you are going toward, as it gets bigger, means like because the face of the multiplier, this division is get bigger, so it gets higher for red, for green, and this one for diagonal, which at the corner it will be 255, 255, 255, and so that's it. So this way we get it like parallel, and we create an image. So so this was the image part. I will finish the other. I will show you another example as well, which is basically using the same logic, but instead of this time, instead of creating an image, this time I'm going to modify it in a way to modify an image. Okay, you might say, what do I mean by that? So this is again another empty template, but I'm going to copy paste this guy and then just change the places I need. Okay, let me show you. This is a famous painting, famous photo. It's called, for example, Lena photo, and I'm going to for this modification, I'm going to omit all the blue parts, like the blue color, and change it with yellow. Okay, you might say, okay, you have RGB. How do you want to put yellow? Well, combination of R and G is yellow, right? So I will just get the yellow part and set it to 0, and then put it instead to the value of R and G. So the blue part are going to be the yellow part. So let's start to work. Let me copy it at the moment, but I'm going to. So I already created an empty project for you here. So this is empty, and inside that I put this image I just showed you. It's called lena.png. Yeah, it is in the Moodle. I will show you how to get it, and but I already just you can upload it inside this form, and you know how to upload the stuff here, right? Just put here and just like upload file. So I upload this file already here, and now I'm going to the same thing, do the same, almost the same things, but this time I'm going to like modify an image. So how to do that? Okay, so basically for this purpose we need the same libraries. So I'm going to, let's say, from I already this utils.png, this utils omp.h and this utils.png. So because I'm going to work with the PNG file, right? And I'm going to get time, let's say. So the same process is same libraries applies, but this time, of course, I'm going a bit faster because I don't want to like make it so long. So basically the same thing. Again, let's print something that's working with Lena something, processing Lena. Yeah, I know it is funny, but see out, and we say, let's say, processing Lena, right? Okay. Okay, let's say image, then they will say, okay. Okay, and of course, std end line. Okay, so we are going to, let's say, print something to the user. Okay, the difference is here. Well, basically, here, we don't have any predefined, like here, we don't have any predefined weight and height, right? Because we don't want to create an image. We want an image which already exists to be, to let's say, modify it. So then I don't have to define anything in advance, except of course the block size, which is just like always. So let's be not to forget it in the beginning. Define like always block size, and I'm going to set it 16 for the sake of consistency. So I have it here. Okay, and here, okay, this time I have to load an image, right? I'm going to load an image which I already showed you, the famous curve, and put it like from the file. I'm going to read it. Okay, so I'm kind of like load the image from the disk or whatever file, let's say, because yeah, it might be in cloud. Okay, using that pngo, which you already saw, it has like different objects to load. You can load an image as well rather than create an image. So basically, if you write png image, and I want it to be png with RGB pixels. So because I'm going to work with RGB concept, so RGB, and of course it's a class template, and it's going to be an image, and like image object. And where is it? Okay, it is here with the name is lena.png. So double dots, which means current folder, and lena.png. So far so good. We just we just made our, sorry, I think this here, I have to put a parenthesis. Okay, so I have loaded my image. Okay, now I told you, since I don't know what is the size of the image, maybe it could be like big image, small image, I don't have any predefined width and height. So here I'm going to get it. How to get it? Pretty simple. So let's define a width and height are going to be number, right? So unsigned, let's say integer, and for the width, it's going to be image. I just create the object and get width. Yeah, that's it. I'm going to get it. The same process for height. And image gets this time height. So these are already predefined when you create an object. So that's it. Good. Now I'm going to allocate a memory. So the same, just like before. I'm going to have a size. So let's say allocate memory. And okay, then I have a size, just like before. Width multiply to height multiply to size of car unsigned car, because you know car is from minus 125 to 128, but when you say it unsigned, it will be from 0 to 100 to 255. So size of car, and of course multiply to 3. I'm not going deep because I already explained why for the previous example. So then let's allocate memory. Allocate memory on host. So it was like define size, or let's say put it together. Yeah. Allocate size and memory. I will call it like this. Yeah. So well, you know how to allocate memory. You say so. It would be like again unsigned char, and a pointer which is like host image. So I have a host image. You know how to allocate memory. Unsigned char star and malloc. I'm just doing the same what I did for the project. Sorry, malloc and how much size? Right, size. So I define the size and I say, get me memory this amount for me. And of course, allocate. And one thing you should know that now I read the PNG file, right? I read the PNG and I want to work with RGB code. So I have to convert this PNG file to RGB format. Okay, so how to convert it? So let's say convert PNG image, which is Lena, to raw buffer because I want to work it with each single cell. So basically, it's for the convert, you use this PVG instead of PNG, and PNG to RGB, yeah, it has it, yeah, PNG to RGB, and my destination is host image. From where? From this image, I just create this object image. So it convert. So it's vice versa. We were like converting after, here we are converting before. So as you know the logic, now let's say allocate on host on device as well. Allocate memory on device. So and so let's define a like pointer. So unsigned, char this time device image rather than host image, and yeah, let's put it null. Okay, and I'm going to allocate it with Cuda malloc. So first I'm going to Cuda check returns. I'm doing it fast because you already know. Cuda malloc. So address of this device image. Which amount of size? The size I just defined here. So here, that's it. So I have put it here. So now here I have to do this copy from host to device. Why? Because I'm not creating something which I don't need it before in the kernel. I have to send this guy I just loaded to the device. So I'm saying like copy from host. You know, this logic is repeating and repeating, host to device. So it is here, and of course Cuda check return. So what should I put to this here? Of course, what you know already, Cuda mem copy. Okay, so mem copy, your destination is device image, your source is host image, and your size is size I just defined, and direction Cuda mem copy, this time from device to host, sorry, from host to device, right? So I'm copying the stuff here as well. I think I missed the one parentheses. Yeah, nice. So just like before, let's configure our kernel as well. I mean, like these dimtree and stuff. So I will say like setting or config, whatever you like. Config kernel sizes. So the thing which I already showed you, like, so you already know, like dim tree first grid size. I will call it grid size, whatever you like, and it's going to be just like before, width plus block size -1. You know, this is repeating, and you get the logic, and divided by the block size. Okay, this was for the height, and let's do it for the width as well. So it will be this. The first one was for the width, and now let's do it for the height as well. So it will be height plus block size -1 as I said, since if it was a square, it was just repeating two same things. But this is not a square. This is a rectangle, so that's why I'm doing this. And this, and of course, it should be multiply to the block size as well. Let me not to forget that block size. Oh, sorry, to block size. Yeah. So this define degree, you know the logic, and again the same thing, but this times for the block size. So block size, and it will be block size to the block size. Just make it two-dimensional. That's it. So grid size. Let me, if I'm not mistaken, anything with plus and minus. Yeah, should be good. We will see if they are going to have an error. So the same thing that we were doing before, running our kernel. Okay, so I'm saying like run the kernel. So let's say what would be the name of the function I'm going to use? Let's say it would be like process image, for example. Okay, and of course you know the logic. Grid to which size? Grid size and block size. I just defined them here. And what I'm going to send here, of course, device image and width and height, right? Because in before I was predefined them like before in advance, and it has access to it, but here it does not. We have to send it, so it will be width and height. So I'm going to send these guys, right? And I hope, okay. So now that I don't know why here it's not okay, because I haven't defined the function yet as well. So now, just like before, we are going to define some function like global function for ourselves. We will come back here as well. So here I'm going to define my kernel. So let me write like define kernel or whatever you want. You already know global, this time void process image. Yeah, I just okay. And what to get unsigned the first time image char star image and weight and height, right? So unsigned int width and unsigned int. Okay, right. Okay. I have created them. So the same logic to get x and y. So unsigned int x is equal to block dimension first. Block dimension dot x multiply to block id x dot x, and this is showing which block we are, and thread idx dot x. So that's it. And the same thing for y. Let me not to repeat everything. So y, but everything will be y and y and y. Okay. So you already know I don't want to go more than the size of my image. So at first I will put the if x is less than, only do this if x is less than width and y is less than height, because I don't want to go outer of my image, right? So pretty obvious. So then I put everything. Here. Okay. So okay, the same process which I do again. Int I, for example, I show you because we have rows. Let me show you here the Leno. Again, we have rows like each row, and then a column which shows the x. So the same thing. So this time it will be like Okay, x plus y plus y which is multiplied to the width, right? The same thing, same thing. Just I put this x that time there on the previous day, and multiply to 3. So I'm getting each like cell, and okay, now the main part. So which was modifying the blue, get the blue and make it yellow. So let's get the blue at first. So I will like call it unsigned, and I call it like, let's say something temp or whatever you want. And I will call it blue, right? Blue is the third one. So it will be, I have an image. The first I is red, I plus 1 is G, which is green, I plus 2 is blue. So it will be I plus 2, right? So so I'm getting the blue one here. Okay, so grabbing the blue. Grabbing the blue. Okay, now I get the blue and I want it, and I want make the blue 0 because I want to replace it. So I will say like replace, say blue pixels, so you understand blue pixels with yellow pixels. Okay, blue pixel and yellow pixels. How should we do that? So let's see if our like value is more than 0, well, which is already is, and what to do here now? I will because it is if it's 0, it's already there is no blue, right? So if there is a blue, because temp gets the blue, if there is a blue, then do the make it yellow. So how to do that? So I have image. So this is red, right? So I will put red to this temp amount, which is blue. I will put this image this time I plus 1 means green again to this blue. I am replacing blue to the red and green, and you know the combination of red and green is yellow. So basically when I put the same blue into the red and green, I'm making it yellow basically. That's it. And of course remove this blue, the blue part as well. So I plus 2 equal to 0. So pretty interesting, right? So basically as you know here, I am saying like if there is a blue, because I'm getting the blue, if there is a blue means more than 0, then put this blue to the red and green, which make it yellow, and make it 0. So that's it for now. And yeah, let's make it nicer. So basically we are manipulating pixels like this. Pretty interesting. So let's go back to our, let's say, our code, and this time, okay. Okay, so let's do the same thing that we were doing for the previous one as well. So we like define a start and finish time. So I've like define start, which is OMP get wait time, and of course we forgot to put Cuda synchronization. So Cuda check return and Cuda device device synchronize. Yes. So yeah, this is, and again this time double end, for example, or finish, whatever you want. OMP get wait time. So I'm getting it as well. And so now let's do something, and which is copy back the result from device to the host. Again, because we did the manipulation, we make everything yellow, and now let's say copy back from host, sorry, from device to host. So you already know Cuda check return, and it's now Cuda mem, sorry, mem, Cuda, sorry, mem copy, yeah, and my destination is this time host image. My source is this time device image. The size is size, you know already, and direction. Cuda mem copy device to host. So we are getting everything back here, and let's fix the parentheses. So we fixed it as well, and now because we want to again be able to write it in the PNG format. So we will repeat everything we just did for the previous one. So I will like convert raw, let's say buffer to PNG. So how to do this? You already know. For converting, you use PNG, and this time RGB to PNG. So yeah, RGB to PNG. So in image, and what is this host image? So I'm going to make it able to save it. So I will make it this guy to the PNG format inside image, and of course I'm going to save it. Okay, then I'm going to image, write. If I have like, let's say some name like Lena, new, for example, .png. So we write it, and let's print how much time we spent. Std cout, and it will be like done or finish. Yeah, finish in some amount of time. You know, the logic behind this example and the previous example, that's why I put it like next to each other, is the same. That's why you know that just some parts, oh, that was about creation, this is about modification. But the logic is the same. We are using same libraries and so on. So yeah, finish, and let's free everything. So Cuda check return, of course, Cuda free device image, yeah, and free host image, and let's save it. So, well, I hope we didn't have any mistakes so far, but yeah, we will get error and we will fix it like the previous time. And you know, I already explained the CMake file, so here again we have to modify our CMake lists file, which is I just copied it, which is the same as I already told you. For example, let's have a name, and I will like yeah. For example, for the sake of consistency, class, and I will call it class. Class. So let me save it, and so the same thing as I told you, like PNG required, OpenMP required, and set the flag for compilation. Then, since we have using OpenMP, yeah, it's you might say, okay, why too much hassle for just getting time? I just want you to know that you can set flags in CMake, and of course, add executable. Since we have two source, we are stating the two different source. This time you say the CPP file, but on the main file, when you import it, you have to import header file. So don't make mistake. So, and here we link libraries together, this class to the PNG library. So let's execute it and we will see how it's works. So let's go to the folders, cd1, and make directory, build. Yeah, you can do it whatever. So I think I still here cd1 because the name of the folder is 1, and then mk directory build, Of course, you can just here right click and create a folder. You don't have to, I think here, new folder. So, but I like terminal more. So cd build, and let's do our CMake. Wishing it works well. So far so good. Let's make our project. Okay, I have an error, which is unexpected declaration 93. So let's see. This is this guy here. 93. Oh, see, I think I rather than 3, this I just put 2. Yeah, sometimes happens. So let's wish this guy like us this time. Okay, right. So if we should have a Lena new if I run it this time, and we will see. Class processing Lena image and done in this time, and we have a Lena new. So let's download it. You see, sometimes TIA doesn't download well. You have to just refresh your file. Let me refresh it. If this happens for you, you just do a refresh with your fix. Okay, let me download it. Yeah, download it this time. So one, and let me go back to the folder. Okay, yeah. Let me extract this guy here again. Same folder, yes, 12. Okay. You see, we have Lena new, and this is Lena. This is Lena new. You see? We just basically, as I said, we just say go to each pixels, but simultaneously. Each pixels, and like until it is smaller than width and height, and if it is more than 0, the blue part, if the blue part is more than 0, get it and put it on the place of the same value, basically same value, put it on the R and G, which is red and green. The result is blue, sorry, is yellow. Okay, and then set the blue part as 0. So that's, you see, like behind all, let's say, calculation in image processing in Photoshop, it's something like this. But we even, not only we just made it, we made it parallel. So it's way more faster on parallel or on supercomputers and so on. So basically, this was this image manipulating was what I wanted you to know, how to open PNG files, how to get width, how to create image, and so on. And so that was it. I know it was a bit longer. And I just wanted you to work with it. And these two examples, well, since I was doing them live, might be, for example, with slightly differences, are available on Moodle. You can find them on Moodle as 2 examples. Also, there is one other examples which I'm going to show you, but you don't have to. For example, yeah, you know the fractal in mathematics. The fractals are something like this. You know, these are being created based on mathematics, and there is an example of this on Moodle as well for this week. You can see it, and if you want, that was like I put 3 examples. 2 of them were guided, which I showed you. You can find the code even here and here. So this time I want you to get used to how to work with it. One of which is creating the image we just made, and the other thing was the Lena, like modification. Again, we just made. And of course, if you like this part and you want to work with it, you can try to play with this fractal as well and create it for yourself as well. So that was it. And you can, as I said, find these examples on Moodle. If anyone has any questions, I'm here to listen. Okay, no question for now. Of course, since I know it's like about codes, about these things, you can send me on the text file, like in the chat part of the this Microsoft Teams. Like if you have a problem, send me your codes, send me your files, and I will try to help you with this. So hope you like this session, and thank you for your attendance. And
Thank you very much, sir.
you're very welcome, and hope you all a good weekend. Bye.
Nice.
Okay, bye. See you.
Bye. See you.